Okay, let's see if we can figure out what this limit is right here. The limit is theta goes to 0 of sine theta over theta. Now, if we tried to just plug in, well, we would get 0 over 0. So that tells us we've got more work to do. Now, to help us with that work, I have drawn a unit circle here. And, I've drawn a triangle in here. This side of the triangle would be cosine, harken back to your trig. This right here would be sine. Okay, so we've got sine here, cosine here. And I'll call this little hypotenuse over here for this big triangle here, I'll call that h. Okay, now let's think a minute about the area of this triangle right here. Well, the area is 1/2 base times height. So I could write that this way. I could say 1/2 sine times cosine. That's 1/2 base times height. Yeah. Now, let's think about extending out a little bit and look at the area of this entire circular sector. Well, this circular sector is not the whole area of the circle. The whole area of the circle is pi times 1 squared. Okay, that's the whole area of the circle. But this is a fraction of that circle. And the fraction is just theta over 2 pi because there are 2 pi radians in the entire circle, and I've got theta of them here, so that gives me the fraction. So it looks like the area of that circular sector is just theta over 2, which is greater than the area of that triangle. Okay, so we have the area of the triangle. Bigger than that is the area of the circular sector. Now let's look for an even bigger area out here, this triangle here. Now this triangle is 1/2 base times height. Okay, that's what it is. Well, it'd be nice if we knew what h was, in terms of sine and cosine. Well, fortunately, we've got similar triangles here. And the similar triangles tells us that 1 is to cosine. Okay. What h is to sine. Yeah, look at that. Similar triangles come to our rescue. Well, that tells us that h is equal to sine over cosine. So let me just put that here. 1/2, instead of 1/2 h, it's 1/2 sine over cosine. So we know that this is bigger than this, which is bigger than this. So we've got kind of a set of inequalities here. Now I've got all these 2's in there. Let me just multiply through by the 2's and clear those out. And then I get this. I get sine theta cosine theta less than theta less than sine over cosine. Now I want to do one more thing. See what I'm trying to do is I'm trying to get something like this. Sine theta over theta. And I notice here in the middle I've got theta. What if I divide by sine? I'll have theta over sine theta, which is almost what I want. So let me go ahead and divide. I'll get over here, I'll get cosine theta less than theta over sine. Okay. Less than 1 over cosine. Now, I want sine over theta, sine theta over theta. So let me just flip everything. Now, when I flip everything, I have to change the directions of the inequality. So this is going to be 1 over cosine. This is going to be sine over theta, which is what I wanted. And then this is going to be cosine. Okay, so I've got, greatest to smallest. Okay, Now, let me do smallest to greatest. Let me just rearrange these a little bit. And I've got this. I've got cosine theta, okay, less than sine over theta, sine theta over theta, less than, see, I'm just using this, less than 1 over cosine theta. See, the inequalities are pointing at the right thing, so I just changed directions a little bit. Now notice, we ended right back up where we started here before we flipped it. So that's cool, it worked out. Now, look what we have here. We've got that this right here is greater than this and less than this. Well, let's take the limits here. Let's take the limit as theta goes to 0 of cosine theta. Well, we know that that's equal to 1. Okay? I mean, if you remember what the graph of cosine looks like, you know, looks like this on both sides. So you can see that limit would be 1. Now let's take the limit as theta goes to 0 of 1 over cosine. Well, that's also going to be 1. So what we have here is we have this limit is 1, this limit is 1, and this one is squeezed in between. So by the squeeze theorem, we can now conclude that this limit is 1. And this is a limit that you're going to want to memorize. This is a celebrity limit, very famous. We're going to use it a lot.